Many major companies run operations on massive blocks of aging ASP.NET software. This legacy infrastructure is a ticking time bomb. On the surface, the applications look solid, but deep within the codebase, invisible technical debt is piling up. We call this technical debt, years of small mistakes and outdated parts hidden out of sight. This code reveals two deep-seated flaws in older systems: faulty access controls allowing unauthorized entry, and insecure deserialization accepting dangerous payloads. When interacting, these vulnerabilities become lethal. Intruders slip through the broken controls, carrying dangerous data straight to the core infrastructure, compromising the whole monolith. These deep-seated flaws make the entire infrastructure vulnerable. It only takes one hacker finding a single vulnerability to bring the system down. For a long time, the only way to find these vulnerabilities was a manual audit by a human. It's like asking one person to manually audit thousands of lines of legacy code hidden inside a monolith. Staring at millions of lines of old code is exhausting and slow. It drains time and forces talented engineers to act as manual laborers rather than builders. When the sheer scale of the legacy code infrastructure is this massive, a human inspector simply cannot see everything. This almost guarantees that a threat will find the holes before the inspector does. To keep up with the sheer scale of the technical debt, we're now weaponizing Copilot to systematically hunt down and neutralize these legacy flaws. An AI can't just be told to find problems. It needs to know exactly what a problem looks like. To guide the AI, developers create custom sets of rules. Think of each rule as a custom static analysis parameter. It feeds the AI agent the exact context of a vulnerability, like insecure deserialization or broken access controls, so the AI knows exactly what to flag. By feeding these rules to the AI, developers can finally point it toward the most dangerous flaws buried in the system, giving it the specific context it needs to start the hunt. With its new custom rules, Copilot scans the entire infrastructure. It checks millions of lines of legacy code in seconds. What used to take a human months of manual auditing now happens instantly. The AI agent identifies a critical broken access control hidden in the legacy codebase for years. Copilot doesn't just find the vulnerability. It generates an immediate context-aware patch. It writes secure code that perfectly resolves the flaw, neutralizing the threat on the spot. This instant patch transforms technical debt into a hardened, secure codebase across the monolith. Generating these immediate context-aware patches turns a legacy liability into a hardened, secure infrastructure. Securing the existing legacy monolith is the first step. But we also have to make sure every new deployment we add is just as secure. In modern software, new code is delivered through a CI/CD pipeline, an automated flow that carries every new feature into the active system. We scale Copilot directly into this CI/CD pipeline. Every new piece of code passes through an automated audit. If code arrives with a vulnerability, Copilot spots it immediately, pauses the deployment pipeline, generates a context-aware patch, and sends it through secure. By making Copilot a permanent part of the CI/CD pipeline, continuous hardening becomes a constant process. Vulnerabilities are successfully patched before they ever have a chance to reach the live infrastructure. The massive ASP.NET monolith is now completely protected against insecure deserialization and broken access controls. By using targeted rules, developers have turned their AI into an elite security guard that never sleeps. Security happens instantly now, scaling with every continuous deployment. By using Copilot as a tactical weapon to automate the hunt, development teams are now transforming technical debt into resilient software systems that patch their own deep-seated flaws before hackers even notice.
Before you head out, let me leave you with a small ask. If this video made your .NET brain spark even a little, hit that like button. It takes you 1 second.